Hi there. So this is the pre-lab assignment for chapter 5. Okay. So questions 1 to 12 are basically asking you to find out the molar mass of sodium chloride, molar mass of potassium chloride, molar mass of potassium carbonate and sodium carbonate, sodium hydrogen carbonate and potassium hydrogen carbonate, and it is asking what are the colors of the flame test for the different elements, potassium and sodium, and then so some conceptual questions which I believe you should be able to answer by yourself. So but I'm going to go ahead and show you how to do the calculations for the pre-lab assignment. So the question 13. Jack measured the mass of empty evaporating dish and a watch glass, weighed approximately 0.5 gram of an unknown, just like our experiment, into evaporating dish, followed the procedure for lab exercise 5 and collected the rest of the data in the table below. Note that row letters correspond to those found on the data sheet that you will use in lab. You will need to refer to this data to answer questions 13 through 20. So the mass of the empty evaporating dish is plus the watch glass given as this amount, and then the mass of the dish, watch glass and the initial solid, this amount, and then after you do your first heating you're going to be getting a carbonate, that's this amount, and then mass of the dish, watch glass and the chloride, which is your final product, and this is the mass of that. What was the mass in grams of the unknown solid that Jack used in his experiment? Type the numerical answer only. Report your answer to the correct number of significant figures. So how do we find out the mass of the unknown solid? That's going to be B minus A, right? B is 65.864 minus 65.362, and make sure to use the proper significant figures. In a subtraction, you go by the least number of decimal places. 864 minus 0.362. That's 0.502. Okay, you do this calculation at 0.502 grams, and when you are entering, don't enter the grams. Okay. And question 14. Use the data given 13 to calculate the mass of the carbonate that Jack obtained after the initial heating of his unknown solid. And that is going to be C minus A. Right? That's going to be C minus A. So the C is going to be 705 65.705 362, and that would be 65.705 minus 65.362, that is 0.343. That's 0.343 is the mass of the carbonate after the first heat. Now we know the amount to begin with. Now we know the mass of the carbonate. Okay, and then question 15, use your answers to question 13 and 14 to calculate the mass loss due to the first heating of the unknown solid. Now for this part I am not explaining you about the experiment because I did explain that in your lab discussion. So before you start performing this calculation, you should watch the lab discussion. So then you know how to perform the experiment and how to do the calculations. And this is like a review for you for all that calculations. Okay. Use your answers to 13, 14 to calculate the mass loss observed due to the first heating. So that is going to be, the mass loss is going to be, so okay, so you're going to be using 13 and 14. So on 13 you have the mass of the initial solid, which is going to be 0.502 grams. Okay, initial solid is 0.502 grams, and after the first heating it became 0.343 grams. So the mass loss is going to be the difference of this. That's 0.159 grams. Okay, and then use your answer to question 13 and 15 to calculate the percent mass loss. So what is the percent mass loss? Is going to be the loss divided by the initial solid times 100. So the mass loss is 0.159. That's question 15. So you take 0.159 grams and then you divide by the initial solid, which was 0.502, and then the percentage you're gonna multiply it by 100. So 0.159 you divide by 0.502 times 100. That is 31.67. 31.67%. So this is a division, and we have 3 sig fig, so it's going to be 31.7%. Okay, 31.7. 3 significant figures. Now, is it going to be a carbonate or bicarbonate? Remember, in our lab discussion video, I explained that if the mass loss due to carbon dioxide and water evaporation is greater than 25%, that's going to be a hydrogen carbonate. If it is less than 25%, it's going to be a carbonate. So ours is 31.7. So meaning our initial solid is a hydrogen carbonate. Okay, a bicarbonate. When Jack performed a flame test, violet colored flame. So what is the violet color? Violet color is for the potassium and yellow for the sodium, and we know it's a 31%, which is a hydrogen carbonate. So the initial solid that he used is then potassium hydrogen carbonate. Okay, refer to the data given in question 13 and calculate the mass of the final chloride product that Jack obtained after reacting his carbonate with HCl. This mass represents the actual yield of Jack's overall reaction. Refer to the data given in question 13. Remember the initial data that we got, and then calculate the mass of the final chloride product. That Jack obtained after reacting his carbonate with HCl, and that's going to be D minus A. So that D is going to be 65.716. grams minus the initial evaporating dish and the watch glass 65.362. This will give us the mass of the final chloride. So in this case, since you started with the potassium, it would be a potassium chloride. So 65.716 minus 65.362 equals 0.354. 0.354 grams. That is the mass of potassium chloride, or HCl. Since ours is a potassium, that's the potassium chloride, and this represents the actual yield, meaning when you perform the experiment, the amount of product that you made. Okay, and then use your answer to question 17 and the appropriate balanced chemical equation in the procedure handout to calculate the theoretical yield of metal chloride in Jack's reaction. M could be sodium or potassium depending on the chemical formula of the unknown. You will need to use 2 of the molar masses that you calculated in question 1 through 6 to solve this stoichiometry problem. So remember, from 1 to 6 you were supposed to calculate the molar masses. So use those molar masses to find out the theoretical yield. Now I also explained in your pre-lab discussion, the lab discussion, that if you had a bicarbonate, remember, first thing, now our case is we know that it's potassium hydrogen carbonate. Okay, first step was you heat it, and then became potassium carbonate plus water and then hydrochloric acid, and then you take that potassium carbonate K2CO3 and then you add hydrochloric acid, that give you KCl plus water and HCl. Now also I mentioned earlier, before you start doing the pre-lab exercises, make sure you watch the video about the lab discussion because it explains these steps. Okay, and then since it involved 2 reactions for a hydrogen carbonate, you need to add these equations together. So the overall equation would be 2 potassium hydrogen carbonate, and this gonna get cancelled, plus 2 HCl giving us 2 KCl, 2 water molecules and 2 HCl. And then we talk about all of these have 2. So then basically you can divide it by 2 to get the overall reaction, 1 to 1 to 1 ratio. So I'm going to go ahead and erase it over here. 2, it'll all become 1 to 1 ratio. Okay. Now we need to calculate the theoretical yield for this calculation. So you started with potassium bicarbonate. What's the amount we started with? That's the initial amount. So initial amount mass is going to be 0.502 grams. That's the amount we use. So you use that 0.502 grams potassium hydrogen carbonate. And then what you're going to do is you're going to convert it to moles using the molar mass of potassium hydrogen carbonate. So 1 mole will give you the molar mass of potassium hydrogen carbonate. I'm going to roughly estimate the molar mass, but you will have to calculate based on the atomic masses from the periodic table. And at the very beginning of this pre-lab assignment also, you need to calculate the molar mass of this properly and then put it in your answer. So carbonate is about 60, hydrogen is 1 and potassium is 19, I believe. Yeah, so 19, 20, 60, so it's about 80 grams. And make sure to use the proper decimal places. Normally the periodic table will give you atomic mass up to 4 significant figures. Okay, so potassium carbonate molar mass is 80. Okay, potassium hydrogen carbonate. Yeah, so carbonate is 60, 61, and then yeah, it looks like 80 is good. Okay, good. In case if these numbers are wrong, don't put me on spot. It's you have to check to see if the answers are correct. Okay, and then because I'm doing all this in my head and I know that you will do proper calculations, I'm just guiding you how to do it. Okay, so 1 mole of potassium hydrogen carbonate, so the molar ratio, And this calculation is for question 19, not for question 20. 1 mole potassium hydrogen carbonate gives you how many moles of KCl? 1 mole KCl. Because we want to find out the theoretical yield of potassium chloride. So 1 mole potassium chloride is the molar mass of potassium chloride, which is 35.45 plus 19, 54.45 grams. So this will give you the theoretical yield in grams. Okay. So let's see, 0.502 over 60. 80 over 80 times 54.45, 0.3416, something like that. So here we have 3 decimal places. 4 significant figures, 3 significant figures. We have 4 significant figures, so it's a multiplication division. We keep the answer in 3 significant figures. So I got 0.342 with my rough calculation, but you guys please calculate the proper numbers that you get from your periodic table, these numbers, okay, with the proper decimals. So that's going to be your theoretical yield. And what was the actual yield? Oopsie mama. Keep. And then the actual yield was 0.354. Something wrong. So how come actual yield is more than the theoretical yield? This is 0.354. I may have done a calculation wrong somewhere, but you got the idea. Okay. 1:1 ratio, potassium hydrogen carbonate. The initial solid was 0.502. Okay. So this is going to be a theoretical yield. Just hold on. Let me check something real quickly. Where did I go wrong? I can correct it right away with you. Let's see the molar masses, if I got the molar masses correct. 58 sodium chloride and potassium hydrogen carbonate. Did we use potassium hydrogen carbonate? Molar mass wrong. Oh, potassium I got 19. That's where I went wrong. Potassium is not 19. Sorry about that. 19 is fluorine. So the potassium is 39. That's what I got wrong. See? I can go wrong too, right? No problem. So we'll fix that quickly. Okay, why are you not working now? Please. No fun. It doesn't. Okay, good. All right. So here's what I did wrong. I got the molar mass of potassium hydrogen carbonate wrong. Potassium is 39. I used it as 19. So that will make this 80 Okay. Let me fix that. It's not allowing me to erase the calculations, but I'll add a new slide here. Slide. Okay, good. We can do it over here. Okay. Sorry about the molar mass calculations. I thought something's wrong. I've been doing it 2 times, but I got the same thing wrong again. Anyway, so let's see. What we need to do is we started with 0.502 grams, 0.502 grams potassium hydrogen carbonate, and then the molar mass of potassium hydrogen carbonate, 1 mole potassium hydrogen carbonate is the molar mass of potassium hydrogen carbonate, which is 100.12 grams, and then the molar ratio is 1 mole potassium hydrogen carbonate give you 1 mole KCl, potassium chloride, and then 1 mole potassium chloride is the molar mass of potassium chloride, which is again 39 plus 35.45. I'm going to take a risk this time. I'm not going to do it with my head. Sometimes head go weird. Like this, 74.55. Potassium chloride, molar mass 74.55 grams. So this will give us the molar mass. So potassium is 39, chloride 35.45. So 0.502 times 74.55, and you divide it by 100.12. Okay, that looks like it. We're going to keep it in 3 significant figures, 0.373 grams. That is the theoretical yield, and this is question 9. Okay, 19. This is question 19. Okay, we have to do that because that's not the correct number. That's not the correct number either. So then I cannot erase this because I saved it. Okay, so that should be your theoretical yield. Okay. Okay, and then we need to find out what is the percent yield. How do you find out the percent yield? Percent yield is actual yield over theoretical yield. I got 0.3737. Okay, it's 0.3737. When you round it, it would be 0.374 grams. Okay. And then the actual number 20 would be, use your answers to 18 and 19 to calculate the percent yield. So the question 20% yield going to be your actual yield over theoretical yield, which is 0.374 grams, and then the actual yield we found somewhere, actual yield 0.354. 0.354 grams times 100. Okay, 0.354 over 0.374 times 100. 94.65. So it's about 94.65 94.65%, and then when you round it to 3 significant figures, it would be 94.7%. Okay, so that's how you would do your pre-lab calculations. for all the questions. Okay. Okay, looks like the rest is all good. Okay then, bye for now.